So in today's class, we'll be looking into some concepts like generics and why we use generics in Java. That's the first thing that we try to understand. And then the next thing that we try to understand is like something like an equals and hash code concept, an important concept in Java. Okay. So now let me create a class and a package. Oh, thank you, Siddharth. So let me create a package com.equals dot. Yeah, okay, awesome. Uh, generics demo. Yeah, better call it class test case. So into this text class, let me go ahead and do, or let me go ahead and copy all the content that we saw in collection framework for array list. Right, let me write a main method. And in this, I'm not interested in explaining or looking into the size or stuff and all. So let me remove some of the stuff, and also not interested in how to do iteration on different types of objects and all. So I'm removing all these things. Iteration, this type, okay, format the code. Now the next thing that we will understand here is why we need to use generics in Java and what is the use of generics. Okay, the first scenario. Let us assume that in the current scenario of array list, I'm trying to add different types of objects into it, right? So like integers, string, and all those things. Now, if suppose if I want to retrieve those objects back and I want to use them, then a simple example that I can show here is, let us assume that at line number 18 we do have something called as an integer. Okay, so after understanding the generics concept, I'll go ahead and explain boxing and unboxing concept, but for means maybe the syntax that I'm going to write here is something related to explicit casting. Okay, why I wrote that and all I will explain later in the next example. So let me say this: int x equal to lst dot get of 0. I want to input, or I want to assign 25, which is the first element in the list, to x. So I will do something like typecast to int. Okay, we'll see this later. Why this and all? We'll see this later. But if I try to print the value of x, anyone guess? Anyone guess what is the output for x, or output for line number 36? Very good. The answer is 25. So if I go ahead and run it, it will print 25 for me. See here, the value of x is 25. Well and good. Now, the next concept here is, let us assume that I want to store either S1 or Naveen. Okay, at line number 20, I'm storing S1, and at line number 24, I'm trying to store, 21, I'm trying to store Naveen. So what I do is, let me assign them again back to an int. So int y equal to, excuse me, sorry, int lst dot get off. This is 0th index, this is second index. Okay, to second index I'm saying, or third index, anything, second or third. So now I will say sys out the value of it. What is the output for line number 37? Error. Okay. What about others? Exception. Okay. So some people say error, some people say exception. Now my question is, at what line the error or exception is thrown? At line number 37. Good. Good. 37. Okay. Very good. So the answer is exception is thrown at line number 34, not at 37. Understand the scenario. What is list.getOf3? List.getOf3 is nothing but it tries to retrieve Naveen, which is a string, and it will be converted into an int. So string cannot be cast into an int. So that is the reason why at line number 34 itself, it will throw an exception for you. So I'm debugging the program, and at line number 33 the program stops. Now I go ahead and say F6. It went to 34. Now if I do an F6 one more time, see what happens. Did you notice it went somewhere? Means it basically it caused an exception. Java.lang.string cannot be cast to integer. Means the output of this highlighted part list.getOf3 is a string that cannot be converted into an int is the issue. So at line number 34 itself it breaks out. Okay. Now what is the output for line number 37 when I do this? List.getOf2. 14. Okay, so just remember that the index starts from 0th location. Null or exception. So the answer is again an exception. So null cannot be cast into an int. So at line number 34 itself, an exception will be thrown. Okay, so if I execute it, same old scenario, exception at line number 34 in test.java. Okay, now the scenario that you need to understand here is the advantage that we get by using collection framework is, means one of the advantages I'm telling, one of the advantages that we get by using collections framework is we can add different types of objects into a list, or in, so which means we can add into a array list or a set or something like that, which means you can store multiple types of objects is one of the advantage. But it has a disadvantage too when the user tries to retrieve the values and try to assign them to some variables like int or something like that. And now let me explain one thing. Student ss equal to, see here, what is that I'm trying to do? At line number 33 I am trying to say list.getOf0 to convert to a student object. Is that an exception or is that a valid scenario? Very good. That is also an exception, which means what is happening in this? While storing, okay, while storing, you can store any type of input like an integer, int, float. For now, it's an integer ideally, but for now, I'm trying to say it as int. Okay. Till the next example, I'll say int. So you're trying to store int, null, or some string or student object like that. You are able to store multiple things, but while trying to retrieve them, if you are unable to cast it to a proper object or a proper variable of a specific type, then it will cause an exception. because of that scenario, in this section you see that there is a limitation in these kind of collection objects in specific scenarios when you want to retrieve the data and assign it to someone else, right? Why? Because when you are retrieving the data, you must know which type of object is being returned back by the list or the array list, right? So that is the reason why there is a concept of generics, which will say that, hey, during retrieval, if you are trying to retrieve it and assign it to a student, if the value that you are trying to retrieve is not a student, then I will restrict it. That is what generics helps us. Okay, generics helps us. See, at compile time, it never complained, but when you use generics, it complains during the compile time, saying that, hey, this is not allowed. That is the complaint it says. Okay, so now let me show an example for generics. So the first and the foremost thing that you need to understand here is generics are used for type safety. Okay, type safety. When you go back to this test.java, and if you observe what type of data that you can store in an LST object, you can store any type of data, right? Now using generics, we will restrict that. So what I will do here is, look at the syntax that I'm going to write. List lst equal to new array list. So everyone knows this concept. Control Shift O, import those. Okay, now the next scenario is when I say a list lst equal to new array list, the concept here is the lst is a reference variable of type array list which can store all the objects, but we don't want to store all the objects. So see how I am adding generics on top of it. And once I add that, I will show an example and I will explain what is the advantage that we get by using generics. Okay, so for using generics, all I need to say is less than greater than symbol, and here I say string, and here also I say less than greater than symbol, I say, yeah, I will explain. Yeah, that's what Sheikh, like I will complete the explanation for this example. I will code it, explain it, and then I will try to give a high level picture of what exactly generics are. But the first thing is, it is for type safety. Okay, so the first thing that you need to understand here is, let me write two statements here. List ls equal to new array list. Now my first question to everyone, what exactly ls can store? What type of data ls can store? Very good. ls can store any object. It's not string theme. ls can store any type of object. Now the next question, if you can answer this, half of the concept is clear to you. What type of data that lst can store? Very good. LST can store only strings. It can never store anything apart from strings. So LST is type safe. LST is of type string. Okay. Now if I say, let me show you two examples here. When I say ls dot add, okay, which we all know, ls dot add, it shows object, which means add or give any object to me, I can store. That is what ls says, which I have declared at line number 11. I'm not interested in ls now. I want to explain lst. Lst dot, when I say add, just notice here lst.add does not take an object now. It takes only a string. Okay, so lst.add of Prabhu, good. lst.add of Naveen, good. Now lst.add of 1 2 3, is that good or bad? See, it's not a valid scenario to add something else apart from string. Now lst dot add of new student or anything, new test class object, is that good or bad? So which means what is happening in this scenario, LST is restricting the type of input that it can take. Okay, so during the input, while you are about to give the input, the LST is type safe and it is of type string only. Now the next question, in the previous scenario you can store any type of object. Okay, you can store any type of object and you can assign, means you can retrieve the data and can assign to either a student or a int or a float or a double or anything. Now see the same scenario here when you try to retrieve the data. Now the first scenario I say is int x equal to int of lst dot get of 0. Is that good or bad? So the answer is that is not allowed. Why? Because during compile time itself, we are using generics and telling that, hey, this list must contain only strings. It must not contain anything apart from strings. Okay, so when retrieving the data, it shows or it tells that, hey, I will store only strings and I can assign or I can give out a value and you can assign it only to a string back. That is what it says. Okay, so writing line number 19 is not a valid scenario. So I say string s equal to lst dot get of 0. And here if you notice, I did not see line number 19 is not valid, so I commented it out. And at line number 20 I did not explicitly use a cast here, like I did not use string here. Okay, so why I did not use string, but in the previous scenarios or previous examples why I used to cast is, in the previous example the input is of type object and the output is also object that we want to convert it into int or a student, something like that. But in this scenario, if you understand, the input is of type string and the output also will be only string. That's why you need not explicitly cast it to string. You can directly assign it to a string variable. Okay. So using generics at line number 13, we are making the LST as type safe variable which can only store strings. Now let me show one more simple example. List ll equal to, or I can declare like this, integer integer. Okay, so see here, when I said list integer means a team, maybe after this example I will explain this concept of boxing, unboxing, integer and all, but for time being understand that integer is nothing but an int value only. Okay, so now list integer ll equal to new array list of integer. Now when I say ll dot add, it shows, hey, I can take in only integers, which means you can only pass 1 2 3 11 23 ll dot add of 56 or something like that. So now can I say ll dot add of Raghu? Can I say that? Very good. I cannot say dot add of. Why? Because I am restricting the type of input that LL can take. Now, if you go back and read this sentence, now I am using generics. The highlighted part integer is nothing but a generic which I am using on an object which is pointed by LL and making it type safe. What is this LL type now? It is of type integer. What is LST of type? It is of type string. So I am making variables, so means this collection objects as type safe. Clear with the concept? Okay, that's good. Now, the next concept that you need to understand here is going back to our very first example that we saw in an array list. The concept here is when I say lst.add, it shows 25. But see here, or any basic example here, here also I can take like int x equal to 5, and I say ll dot add of x. So what is x? X is a variable of type int, and is int an object or not in Java? First question. Very good. Int is not an object. It is a primitive data type in Java. Okay. So that concept is clear to everyone. Now my next question. Since int is not an object in Java, the next question is, can you store anything apart from object into this LL? Means not only to LL, into anything. In our previous example LST, into this object, can you store anything apart from object? Yes or no? The answer is no. Yeah, so continuing with this, so in this concept, the first thing that we understood is like, yeah, the first thing is we can store decimal. No, I think let me take that question. You mean can we store decimal numbers into integer? The first thing, it is not at of type C. Let me say 1.8. So what is 1.8? It is not an integer, but it is a double value in Java. So storing a double into an integer is not a valid scenario, so that we cannot do. We can only store values of type integer only. But if you're trying to store a double value, then you can store integer into it. Why? Because like even if you store 1, it is stored as 1.0, which is considered as a double again in Java. Okay, hope that is clear. Now the first thing, when I say a collection framework, the collection framework, anything, array list or vector or hash set reset, anything in a collection framework can only store objects. But when I say at line number 26, I am trying to assign x to LL, which means x is not an object, but still I am able to assign x to LL. But the concept is, hey, you can only add uh, objects into the collection framework objects. So what is the concept here? The concept is Java has a concept of boxing and unboxing. It means trying to convert a primitive type into an object automatically, and trying to assign that object into, or trying to add that object into a collection framework. And if you are trying to retrieve the data, what exactly comes out from LL? From LL, it only we can retrieve objects. So if I say int y equal to ll dot get of 0, then the first value here, okay, it's duplicate, xyz I say. Okay, so if I say xyz and ll dot get of 0, ll dot get of 0 will give me an integer, which means it will give me an object, but when I try to assign it to a primitive type, how is it possible to assign an object to primitive type? So at line number 28, unboxing is happening. Object is being converted into primitive type, and at line number 26, a primitive type is being converted into an object automatically. So this concept is called as boxing and unboxing in Java, and converting a primitive to object and then storing that into the LL. At this point, it is nothing but a collection object array list, is like a two-step process in Java, right? Converting to object and then storing that object into array list. Now Java says that, hey, instead of you trying to store primitive types, why don't you use an equivalent objects so that compiler will have a less overhead. At line number 26, compiler will have an overhead, an additional step to perform. What is the additional step? It needs to convert the primitive to wrapper class. Now, if instead of using x as an int, if you declare x as an integer, then Java says that x is of type integer, which is nothing but an object representation of primitive type. Okay, so if you go back and understand the primitive data types, you have something called as an int, then double, char, float, like that, right? So each primitive data type, all the 8 primitive data types in Java has their own equivalent wrapper classes. Int has integer, double has double, float has float. Notice here that the classes will start with a capital letter, okay, and every primitive data type except int and char has the exact same name wrapper classes. Int has integer, char has character as their wrapper classes. Apart from that, all other things have exact same names as their wrapper classes. So the wrapper classes are the object representation of primitive data type. Is that clear? Okay. Let me know if you have any questions. Okay, that's good. So hope the concept is clear to everyone. Like why we use generics. So generics are used for type safety, and sometimes people will ask wrapper classes all primitive. Yeah, wrapper classes are nothing but equivalent representations of primitive data types in object form. Okay, so integer x equal to 5 or int x equal to 5 both means the same, but integer means it is an object representation, int means it is a primitive data type representation. Yes, so this will be used in collections framework. Why? Because integer is an object, right? So that will be saved directly into this array list object, so there will not be an overhead for the compiler to convert a primitive to object again. Why? Because you are using an object directly. Okay, so let me take one more question. Someone has asked, like, can you explain line number 32? Okay, line number 32 is int xyz equal to ll dot get of 0. So when I say ll dot get of 0, what is the type of output that I get? The type of output that I get is integer. Now, integer means, is it an object form of data or not? Okay, that's correct. So it is an object form of data. So integer is an object representation of primitive data type int. Now the question here is, how exactly integer is being converted and assigned to xyz, which is of type int? How is that happening? That is being taken care internally by the compiler, saying that it converts the object back into the primitive type. So that is unboxing. That is the concept. Is that clear? Yeah, you can give anything. ll dot get of 1, ll dot get of 2, ll dot get of 0, 1, 2. Anything you can give. Why? Because they are all of type integers only, which you get output. Okay. Yeah, go ahead, Ravi.
Yeah, you said in wrapper classes we'll see int as integer and char as character, remaining all are same, right? Uh, can can you hear me?
No, I cannot hear you, Ravi. Oh, sorry. My mic is on mute actually. Yes, sir. Yeah, can you go ahead now?
Yeah, you said in wrapper classes int is integer and char as character, and remaining all data types are same, right?
Means all
Is
data
that correct?
types will have the exact name. See, you know double as a primitive data type, but
Yeah.
object representation is with caps D, double. Okay.
So, okay, so in wrapper classes, you're saying data types will convert into objects. You
Mm-hmm.
mean like real objects?
Yeah.
Okay, okay. Okay.
Okay. When you open demo.java once. Okay.
Yeah, Raghu, here in line number 23, we are creating an object of student class, right?
23, 23. Yes, exactly.
Yes, in this package, there's no student class, but why it is not showing any error here?
Okay. Okay. Yeah. Yeah.
I mean,
Gotcha.
we are not even
This,
in.
yeah, this demo does not belong to generics package. This demo, if I click on this, it belongs to this collection framework, which is having a student object here.
Yeah, okay, okay. Yes, okay, got it.
Okay. Okay, that's good. Anyone else has any more questions? Okay. Now let me go back and explain one more important concept, like equals and hash code, the most important concept. So just try to make sure that uh, you understand this concept very well. Okay, the most important concept. So class, let me say like com dot java dot equals and hash code. Okay, now here uh, let me say create a student object. So in student object I'll be creating two or three variables: private int id, private string name, three variables, then get some setters, then again like want to create a constructor, Control Shift F, format the code. Okay, done. So this is basic student class with ID, name, age, parameters. Okay, let me close it. Now create one class called demo. So here let me create a main method, s1 equal to new string of abc, string s2 equal to new string of abc. I create. Okay, now I say if s1, I want to just compare the strings, equals s2, then I say this out, same, this out, not same. What is the output in? So the answer is same. Why? Because when it compares or checks the values, it makes sure that it assumes that ABC and ABC, not assumes, it checks both ABC and ABC are same and it returns same for us. Okay, if I run this, it prints same. Okay, the equals method is comparing that. So what is that I'm trying to do? I'm trying to say new string object and ABC. So what is this? I'm just trying to call a constructor in the string class and trying to assign ABC to that constructor. Okay. Now the next example that I say is student ss1 equal to new student of student ss2 equal to new student of. So now in this concept I do have two student objects, ss1 and ss2. Now when I try to compare them, like ss1 dot equals ss2, will it be equal or not? ss1 dot equals ss2. Write this out here. Okay, so the answer will be it is not same. Okay, why? Because Naveen, here it is Raghu, here is Naveen 11, here it is Raghu on 10 and 1 and 2 are, everything is almost, many things are different. Now here I say ss3 and let me say now I say ss1 dot equals ss3. What is the output? Same or not same? Same. Yes, right? Same. Very good. So when I compare ss1 dot equals ss3, the answer is same. Very good. The answer is wrong. The answer is it's not same. Okay. So why the answer is not same? SS1 and SS3 will exactly look like the same objects, like one Raghu 10 and one Raghu 10. Both look exactly the same thing. So why is it not saying that SS1 dot equals SS3 is same? The answer here lies in the equals method. Now if you notice the way that I'm using an equals method at line number 10, okay, if I go into that equals method, or if I try to see equals method, notice here the equals method is present in the string class. Did you notice it is present in the string class? So in the string class equals method, it checks, hey, is the strings that are being passed, means if you understand this concept, the concept is nothing but first it checks whether both are pointing to the same address or not. If they are pointing to the same address, then immediately return true. Why? Because you need not compare anything else. If not, first compare if both are of instance string or not. If it is of string means the incoming thing is if it is of instance a string, then what it does is like it tries to, means the concept all which is written here is nothing but it tries to check each character by character and make sure that all the values that are being compared are exactly the same, like a is equal to a, b is equal to b, c is equal to c. If you have anything else, it will compare all those things character by character, and if everything is the same, then it returns true in this scenario. So that is the equals method, the most important thing. This equals method is present in the string class. Now the next concept, when I use an equals method at line number 20 or 27, that is different from the one that I'm trying to use at line number 10. So let me go back into this equals method. If you notice here, this equals method currently that I'm using is from an object class. It is not from a string class. Okay, it is from an object class. Now quick question to everyone. So based on this, can anyone tell me if the method at line number 10, the equals method, is it equivalent to the one at line number 20 and 27, or is it different? The answer is different. Okay, it is not same. That is what I'm trying to explain here, team. Notice here, the equals method that I'm trying to use here is being or is coming from the string class at line number 10, and at line number 20 the equals method that I am trying to use is coming from the object class, which means both the equals methods at line number 10 and line number 20 are not coming from the same class. That is what I am trying to explain here. Okay, looking at this equals, don't assume that both are being called from the same class. This is a comparison on strings, which is coming from a string class, and this equals, here we are trying to compare objects, which is coming from the object class. Is that clear? Okay, that's good. So the first thing that everyone understood is there are two different equals methods in this current scenario. The first equals method, which is coming from the string class, compares each character by character in every string and then checks if the strings are equal or not. But what exactly this equals method is comparing? Okay, so if I go to this equals method, which is coming from the object class, this equals method checks if both the objects are pointing to the same address location or not. Okay, if both are pointing to the same address location or not. In our scenario, or means there are two objects, SS1 and SS3, that I'm trying to compare. Are they pointing to the same object or different objects? Sorry, not object, I mean to say, are they pointing to the same location or different memory location? Very good. They are pointing to different memory location. Very good. So since they are pointing to different memory location, the answer is false. So Never ever think that it is comparing one Raghu 10 with one Raghu 10. The default implementation given by the equals method in the object class compares if the reference variables are pointing to the same address location or not. Now, the next thing I say is string ss4 equal to ss3. Oh, sorry, not string, student, sorry, my bad. Student ss4 equal to ss3. So I say ss4 dot equals ss3. What will be the output for line number 35? Someone says same, someone says same. What about others? Very good. The answer is same. Why? Because ss4 and ss3 are pointing to the same memory location. But what is the output for line number 28 now? Someone said same. Just make sure that it's not same. It is different. Okay. Why? Because ss1 and ss3 are pointing to different memory locations. Okay. Now, the next concept that we try to understand here is when comparing the objects, okay, when comparing the objects using the equals method given in the object class is not sufficient, means it is not the right way of comparing objects. So now the question here is, what is the right way of comparing objects? So for comparing objects, all you need to do is you need to use equals and hash code. We'll see step by step, one by one. Yeah, means I will explain hash code also. Why hash code and all. Let's slowly understand it. Okay. Uh, So the first concept that everyone understood here is this equals method cannot be used for comparing, which means the current implementation which is given at line number 12 is not sufficient. You need to write your own implementation. Now, can anyone tell me where exactly you can override the equals method? Anyone? In our main method, no, it is wrong. So the hint is like, yes, you need to override it, but where you need to override, in which class you need to override. In string class, that is wrong. In student class, that is the right answer. Okay. So why we need to override in student class? You will explain. You will understand it in a while. Okay. So now what I will do here is, okay, before I explain that answer, now tell me one scenario. When I say ss1 dot equals ss2, I'm comparing two student objects. So now this equals method, where is this equals method present? Okay, so just make sure that check before you answer, team. ss1 is a student. Okay, so it is pointing to an object class method. Okay, so now I go back to the student class, and just maybe for your understanding here, I'll just write one hint, not required. So the equals method in the object class is called. Okay, now in the student, what I will do is I will try to override the equals method. So we need not explicitly override equals method. What I can say is I can make use of Eclipse to generate it for me. Source, generate hash code and equals. Both hash code and equals go hand in hand. Why, we will discuss later, means in the next examples. I say okay. Did you notice here the hash code implementation is removed, and here Control Shift F to format the code. See, equals implementation is given from line number 16 to 24, and from 26 the equals at line number 16 to 24 the hash code implementation is given, and from line number 26 to 45 the equals method implementation is given. Okay, so what exactly is written in this, or what exactly is generated by the Eclipse, we will see later. Okay, means later means coming up I will explain that. Yeah, I will show that one more time. Let me remove equals and hash code. How to generate them. Anytime if you want to generate something like a constructor or a getter or setter or equals or hash code methods, go to source and then say, do you want getters or setters or hash code or toString or constructor, what exactly you want. So in this current scenario I want to generate hash code and equals. See, both methods go hand in hand. Like you need means in general we do both. Why we do both, we'll see with an example also. Okay, so both the implementations came. So equals method and hash code came. Now quick question to everyone, if this concept is clear till this point. Now when I say ss1 dot equals ss2, okay, if ss1 dot equals ss2, at line number 23 the equals method is being called. Now my question is, which equals method is called? Is it the object class equals method or not? Yes or no? Okay, no. The answer is very good. The answer is no. Why? Because in the current scenario when I say ss1, ss1 is of type student. When I say student dot equals, it goes to the equals method given in the student class. It will never ever go to the equals method in the object class for the current student object. Okay, now I will do one more thing. See here, observe very carefully. New class machine. Okay, I have created a machine class. I'm not interested in writing any of those parameters like id name, id name, anything. I say machine m1 equal to new machine m2 equal to new machine if m1 dot equals m2 without frame. So now my question for everyone, there are two things that you need to answer in this. The first one, which class equals is called at line number 18 and which class equals is called at line number 31? Two answers. 18 is object, object and object, object and student. Okay, what about others? 31 student, object and student. Very good team. Those of you who said object and student, the answer is correct. Why? Because at line number 18, when I say a machine object dot equals, it goes to the machine class and checks, does the machine class has any equals method or not? Machine class does not have an equals method. Now, the next question to everyone, what is the super class of a machine class, or from which class machine class is extending some features? Very good, which means machine is extending from the object class. So since the equals method is not present in the machine class, it goes to the object class and looks for the equals method. So in this scenario, in the current scenario in demo.java, at line number 18, the equals method which is being called on the machine class object will call the equals method present in the object class, but anything which is called using a student object, either 31 or 38 or anything below, using a student object will always call the equals method present in the student class only. So this student class equals is called now. Okay, so the first thing is, before you understand the concept of what is written inside this equals and all, first concept, is it clear in which scenario which equals is being called? Okay, yeah, very good. Now moving on to the next concept. So why did we override the equals method? Why? Because when we are comparing objects, ideally if an object has similar values like any other object, if two objects have similar values, our understanding is that those objects must be equal. But what is Java saying? By default, Java says that, means Java will never know, right? There might be a student object or a machine object which will have ID, name and age, something like that. It will never know. So what it does is, it gave a generic implementation saying that compare the addresses. But now, since you know what are the fields that the student object has, what you will do is, you will tell, hey, compare these fields to make sure that the objects are told as equal. So now I'm giving a high level view of what is written in the equals method. Okay, the high level view is, it will take two objects, or it will compare two objects, the current object with any object that you pass, like ss1 and ss2, it is comparing, and it checks whether the id in this is equal to this, whether the name in this is equal to this, whether the age in this is equal to this. Like that, it will compare each and every field and will say whether the objects are equal or not. Apart from this, it compares something else also, but for now, just let me know, is the high level understanding of the equals method implementation is clear or not? What might be written in that equals method? Good. Now in this scenario, when I say one Raghu 10 and one Raghu 10, the concept here is, I want to make sure that ss1 dot equals ss3 must return true for me. Now let us see what is exactly written inside this equals method. The first one that is written is this. This means current object. So there are two objects that I am passing, ss1 and ss2. So ss1 is considered as this, which is nothing but the current object, and it is being compared with ss2, okay, which is of type object, whether it checks whether both are pointing to the same address location or not. If so, straight away say that, hey, both objects are equal. Now, the next concept is, it checks. If this does not match, it did not match, right? Okay, let me do one thing. Let me put a breakpoint at line number 28 and breakpoint at line number 18 and go back and debug my program. Okay, I'm closing this string.class and object.class and machine.class. I'm not interested in that. So let me put a breakpoint at line number 31. So debug it. So the execution stops at 31. So I want to go inside and see what is happening. So I do an F5. So I went inside. What is this? This is nothing but SS1, which is ID1, name Raghu, and age as 10. It is being compared with an other student object, which is 2, 11, and Naveen. So are they pointing to the same address? No, they are not pointing to the same address. Go to the next step. Next. If the object that I'm passing, is it null? So it is not null. If it is null, straight away it says that, hey, objects are not equal, like that. Oh, sorry. Okay, now the next one. Whether the get class is equal to the object dot get class, the current method, the current object dot get class. If they are not equal, which means if you are trying to compare a student and a machine, then this method or this syntax straight away says that, hey, you are comparing two different classes like a student and a machine which are not equal. So that one says false, but both are student objects only. So even it will not go into this 32. So 34. It converts this obj, which is of type object, into student now. Okay, it converts it into a student. Well and good. Now it checks whether the current age is equal to the age of the other object or not. So what happens? Control Shift I. So for other dot age is 11, but the current age for the other object is 10. 10 is not equal to 11. Yes, this condition is satisfied. Once this condition is satisfied, it means both ages are different. So the objects are not equal. So our criteria is, if any property fails, then we will not say that objects are equal. So the first criteria when we are checking SS1 and SS2, the age, the age is what is compared initially. It failed. Okay, don't think that it must compare age first and then ID. It can compare any parameter first. Okay, so it fails. So it has returned false. So it prints not same. Now let us see for SS1 dot equals SS3. So SS1 is 1 Raghu 10, SS3 is 1 Raghu 10. We want to see true in this scenario or same, objects are same. So I go inside F5 and I'm not explaining all those things. Now I'm checking whether both ages are equal. So this age is 10 and other dot age, Control Shift I, is 10. Ideally both will be same now. So ID both are 1 and 1 same. Name, it is not null, other name is not null. So are both names equal? Yes, names are equal. So ultimately, since everything inside the objects are equal, it is returning back true for you. So since it returns true, it prints ss1 dot ss3 is equal. Okay, straight away it prints equal. Now see what happens at line number 45. Line number 45, if you understand, SS4 and SS3 are pointing to same address location in the memory, right? See here what happens, and I say F5, I go here, whether here the first check itself says whether both are pointing to the same address or not. So that itself is true. Once it is true, none of these things will be checked. Means it need not check all these things. Why? Because both are pointing to the same address location. So it straight away goes back saying that, hey, both are true. Okay, say done. I complete the execution. Now, is it clear to everyone like what happened in this scenario and how we are able to compare objects and how we are able to tell that, hey, the objects are equal? Is it clear? Okay, that's very good. Now, the next concept here is, maybe if you have noticed in this current scenario, the hash code, okay, the hash code method is never called. Okay, that's fine, leave it. I will explain you when that hash code is called. Now, the next example that I want to show here is, let us assume that I have SS1 as 1 Raghu 10 and SS3 as 1 Raghu and 12. Okay, and the scenario here is, okay, the business requirement. The business requirement says that if suppose, if for an object, if the ID and the name are equal, then make sure that, or tell that the objects are equal. I am not concerned about the age. Age is not a concern for me. So in that scenario, if I want to tell the objects as equal, what are all the things that I need to compare at a high level? Name and ID. ID and name. Very good. So what is the current scenario that I'm explaining? The current scenario that I'm explaining is, I want to compare objects. Well and good. But what is the business requirement now? In the current scenario, the business requirement is, make sure that if out of, means in your class, there might be hundreds of properties. Out of those hundreds of properties, if the ID and the name are equal, make sure that you say that the objects are equal. Okay, I'm not worried about age or any other parameters. But what is the scenario in the previous scenario that we saw? In the previous scenario, we wrote code in such a way that all the three properties should match with any other objects, all the three properties. Okay, that is what we did in the last scenario. But in this scenario, I want to only check for ID and name. So see how I change my equals method. In the equals method, since I'm not worried about age, I will remove this check. Okay, I don't want to check age anymore. I'm only interested in ID and the name. So I removed age comparison there. Now tell me, if I compare S1 dot equals S3, will it say same or not same in the current scenario? Very good. It will say same. See here. See, this is being printed. Okay. Why? Because it checks whether ID, name are equal or not. Now tell me, in this scenario, I want to check the same old business requirement. I'm only interested in ID and name. Now tell me, will line number 38 will print same or not same? Okay, very good. The answer is same. Why? Because even in this scenario, I'm only comparing ID and name, which is 1 and Raghu in SS1, with ID and name, which is 1 and Raghu in SS1. So even if I say age as 10 or even if I say age as 100, I don't care. Why? Because I'm not comparing ages in this scenario. Okay. Now understand the question and answer it. The business requirement now remains the same. What is the business requirement? I need to compare only ID and name. I'm not interested in age. Okay? I'm not interested in age at all. I want only ID and name to be compared, and I want to say if objects are equal or not. So I undo this age comparison here. Okay? And I compare SS1 dot equals SS3. Will it print same or not same in this scenario? Very good. The answer is not same. Understand the scenario here, team. I think someone told same. It's not same. It shows not same. Why? Because what is the business requirement? Compare only ID and name. But are we coding according to business requirement? We did not code according to business requirement. Rather, I tried to code or I tried to compare age also. So as per business requirement, SS1 and SS3 must be same. But as per your coding, the SS1 and SS3 are not same because you are doing an additional age comparison. Means I just want to show you a scenario how you can modify your equals method based on the business requirement. Clear? Clear to everyone? Okay. Now the next scenario. Here I will explain one important concept of hash map. So these questions are like most widely asked questions like what is hash map, what is hash code, what is equals and hash code, or what is the relationship between them. This is one of the most frequently asked interview questions. Okay, so let me have a machine class. So in a machine class, I say like let me add the same old parameters that I have here: ID, name, age, ID, name, and win number or win or something I say. Source, generate getters and setters. Okay. Source, generate constructor using fields. Control shift format. So see here, I did not write equals or hash code anything here in the machine class. So this will be an error, yeah, because we don't have a regular constructor. Maybe let me go ahead and write a simple regular constructor, default constructor, public machine. Now let me create a class called test. In the test class, let me create a main method, then machine m1 equal to new machine of 1 comma win number machine m2 equal to new machine of 2 comma showing comma 345. Okay, I created two objects m1 and m2. No, we did not write a default constructor in student class. If we want, we can write. If not, we can leave it. Okay. Now, why did it complain in machine class? Okay, it did not complain in machine class. See what happened, if you remember in the demo.java, I wrote a machine class. I created an object for machine class using a default constructor which the compiler has given. Now I just wrote, okay, I hope you got your concept. Okay, yeah, that's good. So now without the hash code is the hash code of m1 is m1 Now so notice here the hash code is nothing but the class name followed by at the rate symbol followed by some random generic value that the Java internal JVM creates or calculates for you. This is the hash code representation of an object M2. Now see, it ends with 55 and it ends with 42. If I rerun it again, okay, 55, 42. Ideally it changes. It must change. Okay, now let me do one. M3, M1, M3. Now, if you notice here, for M1 it says 55 and for M3 it says 42 and for M2 it says 9C. Okay, so it means M1 and M3 you think that they look alike. Okay, they are all same, but still the hash code for them is different. Now coming back to hash code, what exactly is a hash code? Hash code is an internal representation of an object, how the Java tries to represent it or remember it. So using this hash code, Java can identify that it is talking about an object called M3. Okay, so hash code is what is means in general hash code is internally being calculated by JVM. We are not sure like how exactly it calculates, but if you want to calculate or if you want to override the feature of a hash code, you can do that. So m1 dot, okay, I'm sorry here, maybe I need to call here like hash code and I should have explained that. M3 dot hash code, M2 dot hash code. So did you notice here it shows the hash code as 70592 it ends with 65 then 42 then 700. 65, 42, 700. So if you go back into hash code, the hash code is nothing but this is a native method in the object class. So native methods are something which are very much specific to this underlying environment. So based on this underlying environment, whether this is on Windows or Mac or OS or it is specific to that specific JVM which is installed on those machines, they try to decide how to calculate the hash code for a given object. Okay, so the first thing in Java there is a contract which says that at any point of time if you try to, okay, where is this test.java, in Java there is a contract which says that if for an object, any object, for a student object or for a machine object or any object, if the equals method says that both the objects are same, then the hash code must be same. Okay, that is the contract. So now M1 and M3, M1 dot equals M3. Will it be same or not same in this scenario? They will not be same. Why? Because they both are they both point to different locations. Now see here, I go to machine.java and I try to override equals and hash code. Source generate constructor, generate hash code and equals. Now, will the two objects be equal or not? The two objects are equal, right? Now, there is a contract which Java has defined. The contract says that, hey, at any point of time, if the equals method tells that two objects are equal, okay, if the equals method tells that two objects are equal, then the hash code of that objects must be exactly the same. That is the contract between the equals and hash code. Now let me go back to machine.java and do one thing. Let me comment out or remove the hash code. Okay, now it has only equals method in it. Now the next question to everyone. At line number 15, we say that equals for M1 and M3 will say true. Now, the next question to everyone is, according to the concept that I explained, will the output for line number 11 and 12, should that be same or different? Okay, it must be same. In this context, if I execute the program, will it be same or will it be different? Okay, the answer is different. Why? Because when I say m1.hashcode, it says that it calculates on its own. It has its own internal way of calculating. Also, when I say m3.hashcode, it calculates the hash code on its own. It has its own internal implementation. So if I execute this class, did you notice the equals method says, yeah, that is what I am trying to say, Krishna. Now I have commented out the hash code. Now who is calculating the hash code? The object class hash code is being called and the internal JVM is taking its own way of calculating the hash code. So equals method at line number 15 says that both are equal. If that is said to be equal, output for line number 11 and 12 must be same. But is it same? No, it is not same in the current example. So the internal implementation of the hash code does not work for us. We need to give our own implementation of hash code. So we need to again override the hash code also. So I go back to my machine.java and I override hash code also. So now at any point of time, if equals method is uh, said to return true, then you need to use your own hash code method to calculate the hash code. What is written in this we will see later. Okay, but see here, when I say test.java in the previous example, when I did not write the hash code in the machine class, it is showing the hash codes are different, which is wrong. But now when I execute this, see, the objects are same, which is told by the equals method, and the output for line number 11 and the output for line number 12 are exactly the same. Even if I execute again, the values are always same. Is that clear to everyone? Like why we need to override the hash code method? Yes, why? Because it is as per the Java's contract. If equals method says true, then the hash code also must be true. But there is one more clause here. The clause is the vice versa is never true. When I say the vice versa is never true, it means there might be a scenario where different objects might have the same hash code, but that does not mean that the objects are equal. Okay, that vice versa is not true. We will understand that vice versa after looking into this example. So what is this hash code concept that I told? This is nothing but a way of calculating an address or an internal representation of an object form, right? So let us inspect how this hash code is present. Since we are overriding the hash code in the machine method, the machine method hash code is called. So in this hash code, see here team, whatever implementation is given here, you can never ever say that that's the right way of doing. You means that's the only way. I'm not saying that's the right way. It is not the only way of doing. You can write or you can do it in any way that you want. Okay. So here it says that prime number some 31, it is saying result as 1. And the first thing that it says is result equal to prime into result plus id. So, some random number he is taking here and adding it to id. Then he's saying that again prime into result plus, if the name is null, then calculate the hash code as 0. If not, it internally does some hash code calculation for this string. And for this string hash code calculation, if you see this again, it tries to take each character by character, like if it is Raghu, it tries to calculate the hash code for R, then A, then G, like that it calculates the hash code for Raghu, and it adds to this result, and again at last it adds the win number and it comes to this result. Now let me modify this to a little bit something like, instead of 31 I make the prime number as 1. Okay, prime as 1. So see here, previous scenario 918.666.8202. Now if I go back and do my test.java, see it is minus 121.7292, some random number. Now I go back to machine.java and change this complete implementation to some result equal to 1. Okay, this is what I say. Now see here, when I execute this, the hash code for M1 and M3 is same. Well and good. It is good. Why? Because if this statement equals method say M1 and M2 are equal, the hash code for M1 and M3 must be equal. Is it equal? Yes, it is equal. It is both 1 and 1 now. So it is good. Now see here, I'm going to explain the vice versa concept. The vice versa concept is, if the hash code for two objects are equal, then the objects need not be equal actually, which means, see here, the hash code for M3 and M2 both are equal, both are 1 and 1. But answer my question, does that mean that M3 and M2 are equal? No, right? So that is the vice versa concept. For two objects at any point of time, if the equals method tells, hey, the objects are equal, then you must and should uh, get the hash code as same for both the objects. But the vice versa, making two objects or having two objects as the same hash code does not mean that the actual objects are equal. Okay, clear? Okay, that's good. And the next very important thing that you need to understand here is, never ever try to do this. Okay, so leave the default implementation as is. And the next thing that I want to explain here is why equals and hash code goes hand in hand. We understood. The next concept that we need to understand here is, if suppose if the business requirement says that, hey, if in my class if I have three properties, make sure that all the three properties are equal to tell the objects are equal. If that is the scenario, then you compare all the objects like this ID, name, win number, all the three you compare and tell that the objects are equal. Now the contract again that we need to maintain is, if the equals method is comparing three parameters in a class, then in the hash code also use all the three parameters for calculating the hash code. The other concept is, if the business requirement says that, hey, just compare the ID and name alone, you need not compare the win number. Okay, if that is the business requirement, what will you do? You come here and you remove the win number comparison from the equals method, right? Now the change that you need to make in the hash code is, you need not, or you will not calculate the win number for the class. Okay, so I will tell you why. So win number is 125 and here the win number is 123. Okay, now the business requirement is compare only ID and name. So I go back to this one and I remove win number because I need to compare only ID and name in this business requirement. Now tell me, will line number 15 say same or not same? It must say same. Okay, well and good. Now my next question, if it needs to say same, will line number 11 and 12, will they need to show the same hash code or different hash codes? Okay, they must show same hash code. Now see here, what happens if I don't remove line number 17? When I execute test.java, notice here they are told as same. But did you notice here the M3 it is showing a different value, and for M1 the hash code is different. Why? Because in this concept we are unnecessarily comparing or calculating the hash code for those fields that we are not interested in. So this is a wrong scenario. This is a wrong scenario. So the concept here is, if equals method is comparing only ID and name, you also compare only ID and name. Don't worry about the win number. So now if I go back and execute my program, it makes sure that it prints both as same here, and it prints the hash code also same for everything. Why? Because I'm not comparing the win numbers here like 123 and 125. I'm only comparing the rest of the properties in the object in equals and hash code also. Is that clear? So in general, like how many properties you write in equals, the same number of properties you need to write in hash code also for comparing. I'm just repeating back the changes. Okay, clear with these concepts? Okay, any doubts or any questions till this point? Okay, if no, like I'm just going to stop this recording.